Welcome to CS 1401 Video 21.1. In this video, I'll present an overview of the field of computer science, which ranges from mathematics to social science. At the start of our course, I noted that computer science involved doing things with information in ways that are correct, efficient, usable, secure, and economical. The subfields of computer science address these criteria from different perspectives and in different combinations. Broadly speaking, the subfields of computer science can be divided into theory, software systems, computer systems, and information systems. Let's start with theoretical computer science, which focuses primarily on the correctness and efficiency of programs. Theoretical computer science works mostly with mathematical aspects of computers. But even within theoretical computer science, there are different branches. Complexity analysis, for example, involves abstract representations of problems and their solutions. Automata theory focuses on representing abstract machines that take particular input and produce outputs based on different state changes. Research on formal languages develops the rules that define the syntax and semantics of programming languages. The subfield of software systems is even broader still. The branches of this subfield include programming languages, software engineering, human-computer interaction, computer graphics, artificial intelligence, computer security, and more. I'll start with the software subfield that involves programming languages and compilers. Here, computer scientists work on the design, syntax, and semantics of programming languages. Related to this area, in our course, CS 1401, we've seen modular programming, object-oriented programming, and logic programming. Programming also has theoretical components. For example, various algorithms are developed to efficiently solve different kinds of problems. You already saw the binary search algorithm. There are other searching algorithms that approach the task of searching something in different ways. Another major part of research into programming is work on data structures. For example, the linked list is a type of data structure which works best for situations where we don't know how many elements will be stored or where we might want to insert an element somewhere in a list. There are other types of data structures that work differently and may be suitable for other applications. This area of computer science looks at those cases. Still in the area of software systems, software engineering is another major field of computer science. If the writing of individual programs could be called programming in the small, software engineering is about programming in the large, systems built of multiple programs. Software engineering emphasizes the design and development of software based on user requirements as well as the maintenance of these systems. The goal is to produce correct programs economically. Economically building algorithms or applications that solve problems correctly doesn't do the whole job, though. Ultimately, it's the user of the application who will have to use the system to solve those problems. Human-computer interaction, HCI for short, focuses on how to make computing applications or systems more intuitive and user-friendly. Researchers in HCI develop novel ways for people to interact with computers. Results of HCI research include such familiar parts of computers as the mouse and the graphical user interface. Current research topics in HCI include virtual reality and 3D immersive systems. The subfield of graphics, which includes image processing and animation, works with images of different dimensions and how best to model and render them in computers. The screen of a monitor consists of tiny dots called pixels. Each dot can show a different color and brightness. All these dots together create an image. And a major part of graphics research works at the pixel level. The results of this research can be seen in graphic design and in various visual arts and effects. It also includes animation. Movies such as Shrek, The Matrix, and Pirates of the Caribbean relied on significant amounts of research with respect to realistic representation of the characters, artifacts, and events. Video games, too, are built on the achievements of the field of computer graphics. Video games also rely on the area of artificial intelligence, AI for short, which works with algorithms that can make complex decisions based on the surrounding environment. These algorithms are sometimes able to learn from the outcomes of their decisions. Siri in iPhone and Watson from IBM are examples of conversational agents that depend on AI principles. Similarly, the area of automated reasoning develops solutions based on logic and reason. We saw a little bit of that when we explored Prolog in our class. Machine learning also looks at finding interesting patterns in text, images, or other formats of data. Auto-completion of search text in Google, the suggested articles in Facebook's news feeds, or the recommendation of related products in Amazon, all these use machine learning as a way to recommend new items. Computer security is a big concern. Threats to security can be against stored data or against the computer system itself. Research on security includes detection of threats or anomalies, prevention of threats, and modification of systems. So, those are some of the major parts of computer science involved with software systems. Next, I'll turn to parts of computer science that deal with computer systems. Let's first look at computer architecture. As you learned this semester, a system can be viewed at different levels of abstraction. Architecture views computers from a level of abstraction between hardware and software applications. A computer is created with a number of components, including input, output, processors, logic, controllers, and so forth. Individually, all of these components have their own designs and details. The field of computer architecture studies these components as well as how they can effectively communicate and interact with each other. It involves both the hardware and the software that goes with these components. A field related to computer architecture is high-performance computing, or HPC for short. As we develop computationally intense applications, we need more computational power to run these applications. One of the famous predictions of the development of the computer processor came from Gordon Moore, who was one of the co-founders of Intel. His observation, or prediction, was that the processor speed would double at about every 18 months. Surprisingly, for a long time over the past few decades, new innovations occurred at a rate that somehow helped to keep this law true. We saw rapid increases in processing power. At the same time, the size of processors was shrinking. Research in high-performance computing works on taking advantage of the full potential of all this processing power in areas that have large amounts of data or need high levels of computation. These areas include weather prediction, treatment of economic data, developing movies and animation, and going through biomedical and biological data. Related areas of computer science include distributed and parallel computing, where processing tasks are distributed to separate machines or processes. The next area of computer science within systems I'll discuss will be operating systems, that's OS for short, which are programs that maintain the communication between the hardware and the software within a computer. Windows machines use the Windows operating system. On a Mac, the operating system is called iOS, which is a version of an operating system called Unix. Research into OS relates mostly to issues of efficiency. Researchers study areas such as time sharing, memory management, program execution, file systems, multitasking, and power use. Another area within systems involves networking and communications. Needless to say, the internet is a big part of our life. Without it, you wouldn't be watching this video. With the internet, computers everywhere share data and information. This communication between computers takes place via networks. Research on networking looks at developing and maintaining standards and protocols for reliable and efficient communication. It also includes cryptography to ensure the security of data, error-checking mechanisms to ensure correctness of received data, and other security protocols. Okay, those are some of the major areas within computer systems. So last but not least, I'll turn to the subfield of data and information. Data can be stored in different ways, including files of different types: documents, text, PDF, databases. Database design, development, and management are the focus of the area of computer science called database. There are different models and languages that are needed to build an effective database. Databases represent various entities of a system that the database captures, along with the relationships between these entities. Processing the queries in the database and optimizing those queries are important, and a significant amount of research is done here. Analyses of data can produce information, and information storage and retrieval is the area that handles mathematical models of data storage, retrieval, and processing. These models include the Boolean model, the vector space model, and the probabilistic model. And these are all used to retrieve useful information. Google is an example of how to retrieve relevant information when a user searches for some text. Google's particular algorithm is known as the PageRank algorithm. The principle of this algorithm is that a web page will be ranked high in the result of a search if that page is referenced more by other web pages. Well, I've covered a lot of ground, just as computer science itself covers a lot of ground. It's hard to find any aspect of our lives in which computers don't play an important part. In video 21.2, I'll look at that very issue by exploring the impact and ethics of computing. See you shortly.